Welcome to week 4 of our blockchain course. This week, we'll focus on the concept of a peer-to-peer blockchain network. In a blockchain, multiple nodes or computers work together to maintain a decentralized ledger. Understanding P2P networks is critical for building scalable and trustless blockchain systems. By the end of this lesson, you will understand how P2P networks enable decentralization in blockchain, learn the role of nodes in blockchain networks, build a simple P2P blockchain network using Python, and implement block propagation and basic consensus. A P2P network is a distributed system where nodes communicate directly with each other without relying on a central server. The key features here are decentralization, where every node stores a copy of the blockchain and participates equally. Fault tolerance, where the network can communicate to function even if some nodes fail. Transparency. Transactions are shared across all nodes. And then security. Multiple copies of the blockchain make tampering practically impossible. Let's talk about the types of blockchain nodes. We have full nodes, which store the entire blockchain and validate all transactions and blocks. An example would be Bitcoin Core. Then we have light nodes, which store only a portion of the blockchain, and they rely on full nodes for verification. An example, wallet apps. And lastly, we have mining nodes, which participate in the consensus mechanism like proof of work and add new blocks to the blockchain. Moving on to communication in P2P blockchain networks, when a block is mined, it's broadcast to all nodes in the network. Nodes broadcast pending transactions to the network for validation. All nodes agree on the current state of the blockchain and resolves conflicts such as forks. And forks are when two nodes mine different blocks at the same height. Now, I do want to stop here and just simplify the concept of forks in blockchain for you. Now, a fork happens when a blockchain splits into two separate versions. It's like a road splitting into two paths. Different groups of people or nodes follow different rules. This can happen because the network updates its rules, there's a disagreement about how the blockchain should work, or there's a temporary glitch when two people, miners, solve a block at the same time. There are two types of forks. Let's start off with soft fork, which is a small change. Think of this like updating an app on your phone. If you don't update, your apps will still work, but you might not have all the new features. In blockchain, the blockchain stays as one chain. Old and new nodes can still talk to each other. An example would be Bitcoin's Segwit, which is a feature to handle transactions more efficiently. Now, hard forks are big changes. So imagine splitting a class into two because of a disagreement. One group follows the old rules, the other group follows the new rules. Now the blockchain splits into two separate chains. They become independent blockchains with their own rules and tokens. An example would be Bitcoin Cash. This was created from Bitcoin because people disagreed about the size of blocks. Now remember, forks happen because maybe we want to upgrade, like adding new features or fixing bugs. Maybe even disagreements where some people in the blockchain community just won't agree on the rules. And temporary glitches. Sometimes two miners can create a block at the same time. The network chooses one block as valid and the other as abandoned. Continuing on with real life examples, let's talk about Ethereum and Ethereum Classic. So a hacker stole funds from Ethereum in 2016. Some people wanted to reverse the theft, but others believe blockchain rules should never be changed. As a result, Ethereum split into Ethereum, ETH, and Ethereum Classic, ETC. Now, forks let blockchains adapt and improve over time, but hard forks can cause confusion and split the community into two separate groups. I know we talked about a lot, but just in short, a fork is like a split in the road for a blockchain. Soft forks is where everyone can still go on the same road, even if some people use new lanes. And hard fork is two completely separate roads are created. Now let's implement a P2P blockchain network in Python. We'll use Flask to create a RESTful API for communication between nodes. Now, Flask is a lightweight Python web framework ideal for building APIs quickly. And a RESTful API, which is a representational state transfer API, this allows systems to communicate over HTTP using a standardized set of operations such as get, post, put, and delete. Each node in a blockchain can act as a server, exposing endpoints, and as a client, making requests to other nodes. The basic idea here is the nodes will communicate via API endpoints. This code creates a basic blockchain node using Python and Flask. Each node has its own blockchain and can handle transactions, mine blocks, and even communicate with other nodes via RESTful API endpoints. Remember, this code is downloadable in our resource section, so go ahead and download it and review some of these code snippets here. Now we're just going to go over it so you have a full understanding of what's happening in this code. So we have at the top, we have our imports, where we're going to import the hashing library for hashing blocks and proof of work. We have the date time to timestamp blocks. We have JSON to serialize and deserialize blocks. We have Flask for creating those RESTful APIs. We have requests to communicate with other nodes, and then URL parse to parse peer addresses. Now down here, we have our class blockchain, which represents the blockchain and its core functionalities. So the first one, we're just defining how the blockchain will initialize with an empty chain, a list of pending transactions, and let's not forget the Genesis block, which is the first block. There's also create block, as you can see, we're defining that, which adds a new block to the chain, which is the proof. It's a proof of work result, previous hash, which is the hash of the last block, and it just clears the pending transactions after adding the block here. We're going to define adding transactions, which adds the new transactions to the pending transaction list and returns the index of the block that stores all these transactions. We also have last block here, where it's property, and this returns most recent block of the chain. And then proof of work, which just implements that proof of work algorithm. Don't forget, we have the validation of proof of work, which is going to check the hash of the proof. And then last, we're defining the hash block, which creates that SHA-256 hash of the block's data. Moving on, we have class node, the node class. And this handles the API and peer-to-peer functionality. We're going to start off with initializing. So we're setting up the block instance, a set of peers, and the Flask app to expose the API endpoints. Next, we're going to define the setup rules. And this defines the API rules that you will see here. The following, we have transaction new. As you can see, we have mine, we have chain, we have /peers/add, which you can see here. We also have sync, which you can sync. And then lastly, we're defining our start, which just starts the Flask app to any specified port, any port that we specify. Now the last part of this code is the main program. So we have command line arguments, which accepts a port argument that we specify which node should run on. The default port is 5,000. Then we also have the node initialization, which is going to create that node instance on whatever port we have specified. And then lastly, node.start here in parentheses is just starting the node and it starts that Flask API. Now, what I would say is go ahead and review this code. There are some things we did not go over in detail, but if you've been going over your Python studies, you should understand some of these things here, such as at static method or even at property. So we can use tools like curl, Postman, or even Python requests to interact via API to add transactions, mine blocks, sync with peers, and even view the current blockchain. Let's start with curl so we can do some things in the terminal, and I'll show you Postman later. Okay, so since we'll be working in the terminal and we run multiple instances of nodes, I have my PowerShell pulled up, my terminal, and in these two boxes here on the right, we have where we're gonna put our node 1 and our node 2. And then over on our left, we have our basic command prompt that we're gonna run some commands in to run some API endpoints. So let's go ahead to our first one. And we want to make sure that we navigate to where we save our Python file. Don't forget to save your file as node.py, just so you understand that this is the code of our nodes, right? This is where we're going to build and initialize our codes. So we have CD, which is change directory, blockchain, which you should already know, whatever folder it is, mine is in blockchain. So I'm going to enter. And I'm going to start node 1. So by doing that, I'm going to put in Python. I'm going to call my folder, my file name, node.py. I'm going to do -p, which is for a port. And we're going to start with the default port first, which is 5,000. We're going to enter. And then the node is going to run. As you can see, the node is running. Serving Flash app node. And as you can see, it's running on these addresses. And we can press Control-C to quit. Now let's go ahead and run node 2. So let's go ahead and go into our folder, blockchain, and we're going to run the code again. But this time, we're going to specify the port to be 5001. So we can have node 2. We have two nodes running now. Okay, so over here in our command prompt, let's go ahead and use our curl to add node 2 as a peer to node 1. So we're going to use the following curl command in the command prompt. All you have to do is just copy and paste it. I am using Windows. So if you're using Windows, you can literally just copy and paste this code. But if you're using another operating system such as Linux or Mac, you might want to find the correct curl command for your operating system. So let's go ahead and get into my folder and let's run this command. And as you can see, when I ran it, the output came out as message peer added to peers. And you can look over here to our node 1 and you can see that there's been a post, a peer has been added. Okay. What we can also do is add a transaction. So let's go ahead and copy this curl command, which adds transactions, paste it right into the terminal, enter, and it says transaction will be added to block 2. You can see a post was created. You can see the footprint. What's another one we can do? We can also mine. Use this command right here, this curl command, to mine. And it will give you some information here. You have index, previous hash, the timestamp, and you see the recipient is Bob, the sender is Alice. Okay. What else would you like to do? We can also view, well, let's sync the blockchain. Let's use this command, this curl command, to sync. And as you can see, these commands are HTTP requests. So it's like a URL, it's a website, okay? It's to our local. And we ran this command and it says message blockchain has been synced, okay? You can even see here how we're making some changes. And lastly, I want to show you is just to view the blockchain. I think that would be something really cool you can see. Use this command here, and it just tells you the blockchain in the terminal. Very easy. I believe that you should do these commands in curl, but after you've done that, to make it more visually pleasing, we can use Postman. Now let's install Postman. You do have to go to the website, but I do have a link here in the description. All you have to do is click on it, download it for your operating system, Windows, Linux, Mac, so forth. Now, Postman is a popular tool for API testing and development, and it provides that graphical user interface to interact with APIs. So it makes it much easier to send these requests and receive responses and, debug without writing code, as you can see here. So once you have Postman downloaded, go ahead and bring it up. Okay, so here's our Postman. I have a little bit of in my workspace, but for you, your workspace may be different when you first install it. The first thing you want to do is definitely create a collection. So you can do blank collection and just name it, right? Let's just go ahead and name a collection. Let's do class collection. We're just going to call it class collection and enter. So once we create our collection, we're going to want to create a request. So you can come here to create a request, or you can even come right here where it says add request. Now for this request, we can definitely go ahead and change our method from get to post because we want to post something. Let's start off with adding a transaction. We're going to submit a new transaction to a node, okay? So we're set it to post, and we're going to put in our URL. That URL is that transaction/new that we saw in our code. We're going to put that right here, all right? Then since we're posting something, we're going to have to go into the body. So click on body right here. And then with these options, let's click on raw. This is going to be the raw JSON data that we're going to put in here. Copy and paste this snippet of code that's in our resource section. And as you can see, it's just posting the sender, Alice, recipient, Bob, and the amount is 10. Once we have that, we can come over here and click send. And when we click send, it has a message. Transaction will be added to block 3. All right. Really quick, let's just minimize this Postman. Let's go back into our PowerShell on our node, and we can see that a request has been made, a post transaction new. So when you do things in Postman, you can also see it here in the terminal. Let's go back to Postman. What I did is I created a collection called Blockchain Node API, and it has where we add transactions, mine the block, view block, add a peer, and sync the blockchain. I think you should do something as such. And what you can do is you can come in here and manually run one by one. So let's get mine a block. We can go ahead and send. As you can see, it changed the previous hash and it mined. We can go ahead and minimize this Postman, and we can see how we mined a block from our footprint. Let's go back to Postman. We can view blockchain, we can add peer, and we can sync. The same things we did with our curl command. Go ahead and play around with Postman to get a feel with it, because learning and playing with APIs is going to be really great as we continue to develop. Now, the key features with this is we're sending requests. So we're testing APIs by sending that get, post, put, and delete, and other HTTP requests. We can inspect responses. We can inspect responses with viewed. We can view the detail of API responses and their status codes. I've showed you collections where we organize our requests into reusable collections for our structured testing. There's even automation feature where we can use scripts to automate API testing, and just collaboration. We can just share these API documentations with each other. Now for your homework assignment, I want you to set up a network of 3 nodes and then add transactions to one node, mine a block, and even sync the chain across all nodes. Basically, what we just did here. Now, your reflection task is to write a 300-word essay explaining how decentralization ensures fault tolerance and the role of P2P communication in maintaining blockchain consistency. Let me know if you have any questions or need assistance with this week's material.